Assalamu alaikum. Welcome back to my class, dear students of standard 11 and 12. How are you all? Hope you are fine. Now, this is my identification. Me, Mafra Shati, lecturer of physics, Square High School and College. Dear students, in the previous class, I have started thermodynamics. That is the first chapter of your physics second paper. And in that class, I have explained zeroth law of thermodynamics. And today, I will explain first law of thermodynamics. So let's start the class. Before discussing the first law of thermodynamics, we should know the definition of some terms which are related to thermodynamics. At first, system, thermodynamic system. What is a thermodynamic system? A definite quantity of matter bounded by some closed surface or boundary is called a thermodynamic system, where the thermodynamic variables pressure, volume and temperature can be measured. Look, this is system and everything around the system is known as surrounding, and this is the boundary. Look here, a cylinder having gas. So a cylinder containing gas is known as a system, and everything around this cylinder containing gas is known as surrounding. Suppose if you are doing an experiment in your chemistry laboratory and you have taken some chemical substance in a test tube. Okay, so in that time the test tube with the chemical substance is known as the system, and you are doing the experiment in your chemistry laboratory. So your laboratory is the surrounding. Look, here we can see some balloons are floating in the sky. So here there is gas inside the balloon. So the balloon containing the gas inside it is known as the system, and it is floating in the sky. So that is in the environment. So that is the surrounding. Now I will make you clear about surrounding. What is called surrounding? Everything around a system called surroundings. In other words, any system with which a particular system can exchange energy called surroundings of that particular system. Look here in the figure. Here the beaker and there's solution in the beaker. So the beaker and solution is the system. The beaker is placed on a table. So the table and air is the surroundings, and this system is exchanging heat with the surroundings. Look. Look, here I have taken some chemical solutions in the beaker or container. Then this is the system, this is the boundary, and everything around this system is known as surrounding. I think system and surroundings are clear to you. Now I will explain you thermodynamic coordinates. The properties of a thermodynamic system are pressure, volume and temperature for gaseous system. These properties are known as thermodynamic coordinates. A thermodynamic state is defined by the thermodynamic coordinates Q and W, that means heat and work done, are not thermodynamic coordinates. Look, here are some gaseous substance is confined in a container or cylinder, and there is a piston that is on the mouth of the cylinder. So this gas has pressure, volume and also a definite temperature. So those three quantities, that means pressure, volume and temperature, are the thermodynamic coordinates. And if any of the coordinate is changed, then other two coordinates remain constant. Suppose pressure is changed, then volume and temperature remain constant. If volume is changed, then pressure and temperature remain constant. If temperature is changed, then pressure and volume will remain constant. Now I will explain thermodynamic process. Any change of thermodynamic coordinates of a system is called thermodynamic process. Suppose a gas is taken in a container or any cylinder and heat is supplied to the system, or suppose if pressure is applied on the piston, then what will happen? Then the volume of the gas will be changed, volume will be decreased. Then what will happen? The thermodynamic coordinate of the system is changed. So that is known as thermodynamic process. That means any change of thermodynamic coordinates of a system is called thermodynamic process. Now, internal energy. Energy which remains hidden or latent in a system that becomes evident in environmental condition. Does a glass of water sitting on a table have any energy? Apparently, there is no energy in the glass of water if you observe it from macroscopic scale. But from the microscopic scale, if you observe it, there is kinetic energy, which is the part of the internal energy, and molecular attractive forces are associated with potential energy. So this kinetic energy and potential energy together is called internal energy. Potential energy, that means the molecular attractive force, and kinetic energy, which is created due to the random motion of the molecules. And these two energy together is called internal energy. Now I will explain thermodynamic systems. There are three types of thermodynamic system: open system, closed system, and isolated system. Open systems can exchange both matter and energy with the environment. Look, here it is the open system. It can exchange both matter and energy with the environment. Closed system exchange energy but not matter with the environment. Look, it is the closed system where there is a lid. That means the mouth of the system is closed. Isolated system can exchange neither energy nor matter with the environment. Look, here the system is confined in a container which contains insulating material. Okay, so it cannot exchange any energy, heat energy with the surrounding. So the open system exchanges both matter and energy with the surrounding. Closed system exchanges only energy but not matter, and isolated system is that system which neither exchange energy nor exchange any matter with the environment. Let's look at this picture, which will make you more clear about the thermodynamic systems. Look, here hot tea is taken in the cup, and it is an open system because there is no lid on the cup, so it is an open system. Look, here hot tea is taken in the cup, so by evaporation some energy is exchanged with the environment, and also by conduction process heat energy is also exchanged with the environment. But you can ask me, how can it exchange matter with the environment or surrounding? Yes, it is possible. If you put some sugar into the cup of tea, or if you pour some milk into the cup of tea, then matter will be exchanged with the surrounding. Again, if you take some tea into another cup, then it will exchange matter with the surrounding. Okay, but here the system is closed with a lid, then it can only exchange the energy by the process of conduction, but no matter can be exchanged with the surrounding because it is closed. So here I can't put any sugar or I can pour any milk into the tea. Look, here it is an isolated system and the hot tea is taken in the thermoflask. And you know about thermoflask, there is insulating material in the inner portion of the thermoflux, and that insulating material doesn't allow the thermoflux to enter any heat or go out heat from the thermoflux. So it cannot exchange any energy with the surrounding, and as it is closed with a lid, so no matter can be added or no matter can be taken from the system. That means it can neither exchange energy nor exchange any matter with the surrounding, and as a result it is an isolated system, that is in Bengali বিচ্ছিন্ন ব্যবস্থা. I think thermodynamic systems are clear to you. Now I will explain you first law of thermodynamics. The first law of thermodynamics is a special form of principle of conservation of energy. You know, conservation of energy, that energy is neither created nor destroyed, only transformed from one form to another. Scientist Clausius expressed this law in general form. According to him, if heat energy is transformed into any other energy or any other energy is transformed into heat energy, the total energy of the systems remains same. Scientist Clausius defined the first law of thermodynamics as follows, which is called Clausius principle. And the principle states, when heat is supplied to any system or heat is absorbed by the system, then a part of this heat is used to increase the internal energy of the system, and rest of the heat is used to perform external work. That means heat supplied equal to increase of internal energy plus external work. Look at this example, which will make you more clear about first law of thermodynamics. Look, here I have taken some gas in a cylinder, and a piston is over there, which is tightly fitted. And if heat is supplied to the system, here the gas contained in the cylinder is the system. Okay, so if heat is supplied to the system, that means to the cylinder, then what will happen? The temperature of the system will be increased. As a result, there will be random motion of the molecules. As a result, the kinetic energy will be increased. Hence, the internal energy will be increased. And you can see the volume that the gas expands, so the volume increases, and which moves the piston upward. The piston has a weight and it is moving upward direction against its weight. So, and by traversing a distance, so we can see there is application of force and also displacement. So obviously work is done. And from the first law of thermodynamics, you know, heat supplied to the system equal to change in internal energy plus external work done. Is it clear to you? Explanation of the first law of thermodynamics mathematically. So, by applying the first law of thermodynamics, the relation between heat, internal energy, and work can be established. If due to the absorption of heat dq, the change of internal energy is du and work done is dw, then the first law of thermodynamics can be written as mathematically dq equal to du plus dw. This equation is a special form of principle of conservation of energy, and this equation is a mathematical form of the first law of thermodynamics. It is applicable to all the bodies. So in this equation, dq, du and dw can be positive or negative. There is a chart. Dear students, you have to remember this chart, whether when these quantities will be positive or negative, because while doing math you will require this. dq will be positive if heat is supplied to the system, and it will be negative if system loses heat. du will be positive, that means change of internal energy, if internal energy of the system increases, then dU is positive, and if internal energy of the system decreases, then it is negative. dW, if system does work on the surrounding, and if surrounding does work on the system, then it will be negative. So the first law of thermodynamics is nothing but the conservation of energy. So energy before equal to energy after. Look, here a gaseous substance is taken in the cylinder, and there is a piston, and on the piston a wooden block is kept. Then Q amount of heat is put into the system. Then what will happen? The gas expands. So gas does work W, and as a result the piston is moving. The piston is pushed, moving the wooden block. Here the system does work. So the work done will be positive. So heat flows into the system, internal energy increases. When heat flows to the system, then the temperature of the system will be increased, the kinetic energy will be increased, and hence the internal energy increases. Heat flows out of the system, internal energy decreases. Work is done on the system, internal energy increases. Work is done by the system, internal energy decreases. We have to remember these things because of for the solution of the MCQ, you will require these informations. So the change in internal energy of a system is equal to the heat added to the system minus the work done by the system. We cannot measure the absolute value of internal energy. We can measure the change of internal energy, and change of internal energy equal to heat supplied to the system minus work done by the system. Limitation of first law of thermodynamics. It does not explain the direction of process, means no given direction of flow of heat. That means heat flows from which direction to which direction. It is not given in the first law of thermodynamics. And it does not differentiate between heat and work. From the first law of thermodynamics, we can see heat and work is convertible. That means heat is converted to work. But from practical experience, this is not true. Heat is not completely converted to the work done. First law of thermodynamics is a special form of conservation of energy, conservation principle of energy. According to first law, if heat energy in a system is transformed into another energy, or another energy is transformed into heat, then total energy of the system becomes same. That is why the first law of thermodynamics is a special form of conservation principle of energy. This type of question can come in your realization based question. That is why first law of thermodynamics is called a special form of conservation principle of energy. Look here, energy transformation. Here sunlight is falling on the solar cell, and it is converted into electrical energy, and electrical energy is converted into light energy. Okay, so conservation of energy tells us what? Energy in equal to energy out. These pictures also explain energy transformation. Chemical energy is transformed into kinetic energy. Here light energy is transformed into chemical energy. You know, plants make their food on their leaves by using the sun, using sunlight, and so in that case light energy is converted into chemical energy. In this way, energy is always converted from one form to another form. And first law of thermodynamics is a special form of conservation principle of energy. I think from the above explanation, you can understand first law of thermodynamics. So let's do a mathematical problem now. There is some gaseous substance in a cylinder. If 800 joule heat is supplied to the system, then 1200 joule work is done. Calculate the change of internal energy. Okay. So first you must decide the sign of W and Q using the convention discussed earlier that I have shown in the chart. When work done will be positive and when heat will be positive, when internal energy will be positive. So work is done by the system, so work done is positive, that means that is plus 1200 joule. Heat is supplied to the system, so Q is also positive, plus 800 joule, and we have to find out the change of internal energy. This is the mathematical formula first of thermodynamics. Del Q equal to del U plus del W. So therefore del U equal to del Q minus del W, and it becomes 800 minus 1200 joule, and it comes minus 400 joule. So here this negative sign indicates what? This negative sign indicates, this result indicates that the energy of the gas is decreased by 400 joule. These type of mathematical problems are given in your book. That means the books you are following, that is written by Dr. Shajan Tapon or Amir Hussain. Any of the book you can follow and you have to practice. But this type of mathematical problem can come into your MCQ question. Dear student, today I am to finish my lecture. There is a nice moral for you that is given by Sir APJ Abdul Kalam. I am not handsome, but I can give my hand to someone who needs help, because beauty is required in heart, not in face. Dear students, in this pandemic situation, many people are homeless, many people are workless, many people are foodless. So you need to be supportive to them. Socially, you need to be supportive to them. Thank you for watching my class.